priority is put a 2-6 up here, because I forgot to number it in my file. So that you're organized in your binder, put a 2-6 up there. You can put M7 if you want, but that's the number one top thing that we need to make sure we have there. So, let's say we're throwing our dog a birthday party. Today, actually, and we don't know this officially because we adopted Marley, but we were told that Marley's birthday is, Marley, my German Shepherd that we got, is some point in October, so we decided that her birthday's Halloween. So today is Marley's birthday party, or her birthday. So Marley's now officially 1, and she's 80 pounds. She's a giant 1-year-old puppy. Yeah, we just took her to the vet a couple weeks ago. So let's say we're going to throw a birthday party for Marley. No, I'm not that crazy, but let's say we're going to. And we're going to buy some treats. We know there's 2 different ways we could set this up. We could set this up proportionally, and we could set this up not proportionally. What's a way that I could make a proportional relationship with buying dog treats? Abby?
Maybe like how many dogs per treat or something?
Yeah, how many dogs per treat? But that might get a little dangerous if I have multiple dogs sharing one treat. What would be a better way to do that?
Flip it around.
Yeah.
How many treats per dog?
How many treats per dog? So like how many treats do you think we should buy for each dog?
Since you have 3 dogs, maybe.
And we're going to invite the neighborhood dogs, right? It's a dog party.
Maybe
One's not really that much.
It costs like $3 to $5, so maybe 1 or
2
2.
treats? Let's say 2 treats per dog. They get a treat when they come, and they get a treat when they leave. So, we could say that treats will equal 2 times the number of dogs. Or y equals 2 times x, where y is my number of treats, and x is my number of dogs. Now let's say we're going to give every dog 2 treats, but I'm going to give Marley 5 treats because it's her birthday.
Oh, yeah.
It's birthday girl. So that would then be the treats will equal 2 for every dog, plus Marley gets an extra 5. This addition beyond the number times the x. This makes it not proportional. So if I only had the y equals 2x, we would be proportional. But as soon as I add or subtract anything else on, it's not proportional. And if I went to graph it, like right here, would I still graph a straight line, like will my line continue straight? It actually is a straight line. It just doesn't start at 0. It would start at 5 treats for Marley, and then every dog that shows up, we're going to have 2 treats for each of them. So it would be a straight line, but it would not go through the origin, and that would be why it is not proportional. To be proportional, like my graph over here, would be 2 treats for every dog. We just start at that origin point. 1 dog would be 2 treats. 2 dogs, 4 treats. 3 dogs, 6 treats. And so on and so on. Any questions on proportional versus not proportional? We have to have this in the y equals something times x form. And guys, I will tell you this is on the test and people are struggling with it right now. What is... Because right here we have y equals 2x. What is this 2 called? Abby?
Isn't it? Wait, it is. I remembered. I was going to say constant, but that's not right.
You're really close. Anthony?
Independent variable.
Ooh, my independent variable is the x.
Wait.
My x, remember, that is independent. My y is dependent. CJ? We don't know yet. We haven't wrapped up the chapter, so I'll give you at least a day's notice. It will not be tomorrow. Yeah, it'll be this week at some point. This is the last section for this chapter. Grace? This number, your multiplier there, is the constant of proportionality. If you don't remember that, you need to make a note of it. It's on the test. I'm telling you right now. It is on the test.
I'm just going to guess that your dog is a rescue.
Is what?
I'm gonna guess that your dog is a rescue.
Yeah. Yep. We saved her from the pound. I cannot stand to see dogs in the pound.
My old dog was, but
That is why we have 3 dogs now. The first one we bought, he was the runt of his litter, and like nobody wanted him, so we kind of felt like, oh, well, we'll take him, because like he was the only dog left. So we bought him. Then we adopted our second Siberian Husky, and then we adopted a golden retriever. They're both Siberian Huskies, but they're different types. So, if you have a map showing 75 miles for every inch that you measure, just like over here, I don't remember what the scale was on the Ohio map. It's 1 inch equals...
Wait.
No. It's not actually very much. 1 inch over there equals 11 miles. So that's not that crazy. But like if we had a U.S. map, it'd have to shrink things down way smaller. That's not too terribly shrunken down. That's a pretty big map. So if we had a U.S. map and it shrinks it down to like 1 inch equals 75 miles, would this be a proportional relationship? Atticus, what do you think? If 1 inch shows 75 miles, is that proportional? So think about the graph. Think about our example up at the top. Would it be a straight line? Would I have the origin point 0 inches is 0 miles? Would 0 inches be 0 miles? Let's start there. Yeah, if I have no distance between 2 points, they're in the same location. Then, what would like 2 inches be? If 1 inch is 75, you can always pass this off. But just think through this. Would it be proportional? You want to choose somebody or on me too?
So 2 inches is going to be 150 miles.
What about 3?
3 is going to be 225.
How are you doing that?
You just add on 75 miles for each inch.
So what about like 10 inches? You're going to add 10 times?
Basically just multiply up.
So we're really just multiplying. So we could say the number of miles will be... How were you just calculating your miles? You just told me what you were doing. Multiply by what? What number were you multiplying by? 75. So it's going to be 75 times the number of inches. And this is why we don't use I really ever. So we could either say like d, the distance between, or we could just set up our equation y equals 75x, where y is miles and x is inches. And again, our 75 is that constant of proportionality. Make sure that you notate that so you remember it on the mastery. It's how my values are proportional with each other. So try this on your own. And by on your own, I mean you can talk with people close to you about this. We want to fit, bless you, we want to see if a bed 3 feet wide and 6 feet long will fit into this space. So we need to calculate this 3/4 and this 1/2 of an inch. How many feet will that convert to when I see this scale right here? 1 inch is 10 feet. So chat with people close by you. Try to figure this out. Will our bed fit into that part of the bedroom?
All we had to do was measure all my walls.
You can solve it a couple different ways. It depends on how you're doing this.
So would you explain like how would you know?
it's not fully 10 feet.
So we talked last week a little bit.
I know where you're
We
going.
talked last week a little bit about how to know how to set up your constant of proportionality. I could use 10 feet over 1 inch, or I could flip this, and I could use 1 inch over 10 feet. Does anyone remember how I choose my setup? What goes where, and what's going to plug into the different things? Like, what do I have to plug in this problem? Do I have inches to plug in, or do I have feet to plug in? Casey? What do we know to plug? Not looking here, looking at the problem itself. We have inches to plug in, right? So since I have inches to plug in, what I plug in goes into the x. So did I set up my constant of proportionality correctly, or do I need to flip it? How do we remember? Abby?
Wouldn't it be like the other way around? So are you trying to cancel something out?
We are trying to cancel something out.
Whoa!
But let's check this out. If I plug in inches for my x, so my r right here is representing the real distance. The real distance, I have my constant of proportionality times my input value, let's say 3/4 of an inch. And I'm going to put that value over 1 to make it a fraction, even though 3/4 already was a fraction. Now here's the thing. I can either do 3/4 on top, and this is now a complex fraction, a fraction inside of a fraction. Or I can set this up as 3/4, and your label just belongs on the top. So either way that you decide to do this, all we care about is the denominator of your constant of proportionality has to match the input label. So the numerator of your constant of proportionality is going to give its label to the answer. So this becomes 30/4, which becomes, anyone figure it out? Go ahead.
Isn't it 6?
Ooh.
It would be
Close. 7.5 feet. So that bed does fit long ways. If it's 6 feet long, it does fit. So let's do this again with the input. What's my other input going to be now, though? If I'm not using 3/4 now, see, a half, right? My half right over here. So erase this. Replace that with 1/2 inch. Now the thing you have to remember is the label belongs to the numerator. So now my inches still cancel out. What's half of 10 feet? 5 feet. Does the bed fit? Yeah, if it's 3 feet this way. So if I were to kind of draw it, it'd probably fit right about like this. A little bit of space for some end tables. There you go. Not if you like it dark when you sleep.
Oh,
I like it really dark.
I love that. I like that.
Izzy?
I hate it.
Hey guys! I called on Izzy and I can't hear.
Please have Gunnar Langhart to the office. Gunnar?
So if you can figure it out, you're fine. I'm just showing one way to get there. There's a lot of right ways to solve these problems. So, same apartment. New problem. We want to paint the long wall of the living room. So here's our long wall of the living room. And it is 9 feet high. We want to put a double coat of paint on it. So we need to first figure out what is the square footage or the area of the wall. Then, if 1 gallon of paint covers 350 square feet, will 1 gallon be enough? So, if this is 2 inches wide on the drawing, how many feet wide would it be, and how do we know? Casey, we'll come back to you on this one.
Okay, it's 20 because it's 1 inch 10 feet. Oh, wait.
Yeah, you're right.
Okay.
If 1 inch is 10 feet, I'm just explaining as you say it, then we have 2 inches for the wall, and to go from left to right, we multiply by 2, kind of obvious, yeah, and we get 20 feet, so the wall's actual length is 20 feet. So guys, if I just got done writing, and I see you not writing, I know you're not faster than me, because you probably can't anticipate. Yeah, except I know that some of you haven't. So then we gotta find the area. We now know how long it is, but we need to find the area. Xavier, how do we find area? Yeah. Multiply what?
The length
Times.
times the width.
Yeah, whatever else we have. So guys, don't get hung up on what we call these things. Length, width, height, width. It doesn't really matter. Here, we have how long is the wall and how tall it is. So I'm just going to say length and height. Yeah.
Do you do L like that? Because a regular L will just look like
It'll
a
look like a
1.
1. Yep. So my length, we just said, was 20 feet. My height, how tall are the walls? 9 feet. So my area here becomes 180 feet squared. Make sure you have a label on that. Then, if I have to do a double coat, well, I'm going to have my 180 square feet. Shane, what do I do since it's a double coat? Yeah, we got to multiply by 2, and what do we get? So, is 1 gallon enough to cover? No. Technically. Now, this is when being an adult is tough. And you have to make those decisions of, do I buy, and because paint, you have to have mixed, right? Like, once you buy it, you've bought it. If you take it back, depending on where it is, they'll give you your money back, or they'll give you some of your money back, or they might give you a different paint. Or like, but getting paint mixed, like, you've essentially claimed it. Like, all the paint on the shelf is not colored. It has to be mixed. So, if this was me, and I knew my wall, my gallon covers 350 square feet, and I have 360 square feet to paint, I'm probably going to try to squeeze it out. Now, if I had to cover like 400 square feet, then I'm probably going to go ahead and buy extra paint. But it's so close that that's one of those hard decisions to make. Abby?
Yeah, like, I would say, like, if you would want, like, safe paint, I would, like, just, like, get a thick paint. Like, I just don't want to get thick paint.
But then it actually goes up. It uses more paint more quickly. The thicker the paint is, but then if I get a better paint, I could only maybe single coat instead of double coat paint. So that, like, it's what do you spend your money on?
They also sell, like, tiny little paint cans, so you can get
Yeah. So quarts, though, how many quarts are in a gallon?
4.
For a quart, so listen to this and see if it makes sense. A quart of paint normally costs about $9 or $10 for a quart. For nicer paint, it gets upwards of like 12. A gallon, hey ladies, can we stop the side conversation? A gallon costs about 25 to 30. So if there's 4 quarts in a gallon, and a quart costs like $10, and a gallon costs like 25, is that really like equal pricing? Essentially, yeah. Because if you buy a quart and then you're like, oh crap, I ran out, and you buy another quart. Now you spent like $20, but you've still only bought like half a gallon worth of paint. And if I run out of paint again, and I have to go buy a third quart,
That's like
I've now spent more money than I would have spent if I just bought a gallon. So that's one of those times where if you buy a larger quantity, you save money. But if I don't need that much paint, it's like, well, which do I buy? Do I think a quart will be enough, or do I like buy extra? It's one of those hard decisions. We're going to go travel to China. China uses, and I always say this wrong, it's not the yen, it's like the yuan. I can't say it, but it's, yeah, the yuan or something. Their currency. Now, we have two different banks that we can go get our money converted at. We're going to exchange our money at either Bank A or Bank B. So I want you guys to draw a little line, separate this problem. We got Bank A and Bank B. We need to figure out which exchange rate is better. So we want to figure out how many dollars I'm going to get back. Before a trip to China. So since we're headed there, I want to know how many yen they're going to give me. So I want to know how many yen for a certain amount of dollars. So I need to know the exchange rate. How many yen will I get for my dollars? This is one of those situations where you have to determine how do we find our constant of proportionality. Because yen is the output that I want, and dollars is my input. And we could go back to our constant of proportionality lesson. We know that the constant of proportionality is always the y value divided by the x value. Here, the yens are my y, the dollars are my x, since it's going to be my input. So all we got to do is do any of the yen divided by any of the dollars that match up. This one's easiest. Why? Anthony? The 100 makes it the easiest. So we set up 640 over 100, and we get 6.4. So my equation becomes y equals 6.4 times d, or you can make it times x. It doesn't matter what variable we use. As long as we know that's our input, that's our independent. Try that on the graph. Pick a point, figure out what's the y value, what's the x value, and do the division. So we have to be strategic with where we pick our points. I want a point that happens where the lines cross each other. So I could pick this point might be good, this point might be good, this point might be good, or honestly, this point might be good. Bella, if I asked you to pick the point, which point would you choose? The 65 and 10, which actually, be careful, if we say that correctly, it's 10, 65, but I know what you're going for. So my y, my vertical axis, is 65. My x, my horizontal axis, is 10. So I get 6.5, which makes my equation, the yen I get will be 6.5 times my dollars. Which bank is better? Bank B. You get more yen. The bigger this number is, the bigger your constant of proportionality is, the more money that you get. So Bank B is better because you get more money. Of course we want more money. And that's like more money for nothing. Literally, you're just handing them US dollars, and Bank B just has a better exchange rate than Bank A. Justin?
Trump just like hand in all his money and get like extra rich?
So you're not getting, this comes down to the difference in like, you're not actually getting a different value when you exchange your money. You're getting back the same value of what you gave them, just in a different currency. Now, some people, though, some banks don't have instant exchange rates, although most banks these days with the internet and how good it is have instant exchange rates. This would be like if Bank B updated on Monday and Bank A updated on Wednesday or something like that. They updated different times. So if I was really, really smart, I could go find the bank with a better exchange rate and get all my money converted to yen. And then I could go and convert it back and do this kind of over and over. And I could make a little bit of money, but that's really, really tough. And the exchange rates are constantly fluctuating. I could easily lose a bunch of money by doing that. There's no guarantee because the exchange rates are constantly changing. It is kind of like gambling. Except actually, gambling, you could, the odds, you have more probability of winning more money. Now you have a higher probability of losing all of your money, but if I win, I get a lot of money. And we're going to talk about probability here in a few chapters.
Yeah, you wouldn't get more money because you can only use Chinese currency in China.
Right, but then I could convert it back.
Yeah, but if you convert $640, if you didn't spend anything in China, if you had to give all of that back, you'd still get $100.
Right. Now this one we want to divide also. Sorry, my graph doesn't divide perfectly out. So try to divide this. You have the rest of the page to deal with this, though. So some important information. Your friend's scale is represented by the equation y equals 1/12 x. That's your friend's scale. But for your friend, x is the actual and y is the scale. So on your friends, the scale drawing will be 1/12, sorry, not 1/2, 1/12 of the actual. So if I replace y and x with scale and actual, that's what I end up with. Any questions on how I figured that out? So one thing this immediately tells me is my scale is smaller, because 1/12, when I multiply by a fraction, I get smaller numbers. So then my graph, or my drawing, is over here, represented by this table. So I look at this point right here. I have 10 and 1, or 1/10 if we say that point properly. So that's 1 inch and 10 feet. Now wait, so if x was the actual, then this actual is probably in feet, and this scale is probably in inches. So here, this was his x value, and this was his y value. My y value, is my y the scale? What is my y labeled as? Actual distance, not scale, not the map. This is the actual. So here's the issue here. My friend and I have flip-flopped our x and y's. So when I solve my constant proportionality, I can't just directly compare. So to get my constant proportionality, m equals y divided by x. So I set up 10 divided by 1, I get 10. So my equation is y equals 10x. But here's the problem. My friend's x and my x are not the same thing. So that's where you have to be careful. The driveway is actually 180 feet long. We want to calculate how long will it be for my friend's drawing, how long will it be on my drawing. For my friend's drawing, where should the 180 plug in to that equation? For the 180, where would that plug in? Joe, what do you think? There you are, Joe. So is the 180 the scale distance or the actual distance? Yeah, because your driveway is 180 feet long. So when I come over here to plug in, that's going to tell me that my scale distance will be 1/12 of 180. And 1/12 of 180 what would 18 divided by 12 be? Well, that would be like 3 over 2. Divided by 12, essentially. I believe it's 15. So on your friend's drawing, your driveway is 15 inches long. Which, by the way, that's a huge driveway. 180 feet. That's like half a football field, including the end zone. Your drawing, though, which, the X or the Y, which was the actual distance? Lily? So I'm looking for X or Y. Which axis? The Y, right? So since the Y is my actual, here my 180 has to plug in for the Y. This is where people will try to make a mistake. They'll try to plug the 180 in for X again. It's not the X value, it's the Y value. So, how do I get X by itself? We got to get rid of this 10. Hayden, how can I do that? Divide by 10. What's the pencil issue? And then we see whose map will be longer. Like who, when you draw the map, yeah, ours. And by how much? Well, the difference between 18 and 15 is 3. Do we have any questions from the homework? Because I have like 4 minutes left. Do you have any questions from the homework that you'd like to go over full group? You're just like, man, I was struggling on this. I bet some other people were struggling on this. Yeah.
I figured this out, but it was this homework, and it was it probably was one of the only people who used it. It was the one where you had 2 fractions and then like a letter on one of them.
Like solving a proportion, just where there was one unknown.
Yeah, there was a little.
Do you just want me to like make up an example, or do you want me to pull up
Sure,
the?
just make an example.
So, anytime we go to solve a proportion, let's say, and I'm actually going to make this like really nasty. And I'll make it nice. So, here, if I wanted to solve this proportion, I could ask, how does this happen? And here it would actually be times 12. But if I can't figure that out, we can always cross-multiply to solve. So we would get 3 times 84 equal to the other cross-multiplication of 7 times z. So then 3 times 84, let's do that multiplication, 240 plus 254. We then have to get rid of the 7 because we want z by itself. And we would just divide, sorry, not divide by z. We're going to divide by 7 to get the z by itself. And I would get that z equals 36. Now, this will work no matter where the variable is. No matter where it is, I just cross-multiply whatever side ends up with the variable. I just divide by whatever number is attached to it. Any other questions? We still got a couple minutes. Is that a hand or no? Okay. So, this is the end of chapter 2. We will be taking your mastery at some point this week, probably on Thursday and Friday. I'm going to budget 2 days for it. So, if you are only behind by 1 assignment, and by the way, I'm not looking at 2-6, because 2-6 like just really is assigned today. If you're only behind by 1 assignment, I'm not emailing your parents. So if you're only missing one of those, whatever. But if you're missing multiple between 2-1 and 2-5, things that should have been done last week, then you should think about, when I go home, how do I frame that conversation with my parents? And here's the best thing to do. When you get there, whether or not they've checked their email, if you know that you're behind right now, assume they're getting an email. And maybe if they don't, then whatever, you rat yourself out. But if you have more than one assignment behind, they're getting an email. You should start the conversation. You should take charge. Say, hey, Mom or Dad, I know you got an email today by Mr. Hudson. I know what it's about. This is what I am behind. This is what I got done at school. Here's what I still need to do. Here's my plan to do it. X, Y, Z. And then your parents will be like, wow, okay, well, they're on top of it. They're aware of it. They're good to go. Please come see me if you need help. Call me, text me. I'll take a break from passing out candy to help you with your math homework.